Manisha.
Good morning, ma'am.
Yesterday we covered machine learning introduction, different basic methods to simulate a kind of intelligence in machine, and also started with supervised and unsupervised learnings. We will continue the same topic, supervised and unsupervised learnings. Let us quickly recapitulate. Supervised learning, uh, in which the input and output both are specified, and what happens is machine has to go through the training phase and has to check whether the output that it has obtained through the process same as the actual output which is mentioned in the data set. If both are same, that implies that the machine learning algorithm has worked properly and the generated output is same as the actual output. Supervised learning analogy can be taken as your teacher will teach you, for instance, A to Z, and then ask you by showing a letter, what letter is that? First they teach you and then they ask you. So teaching is like training phase, and then asking you is like a testing phase of this supervised learning. Moving on to unsupervised learning. In this kind of scenario, outputs are not given, only inputs are given. The system has to ensure that it forms a group of all related objects together and come up with a clusters of similar kinds of objects. For instance, if a teacher gives you mixed of characters and numbers and ask you to do something with the data, and what you essentially does is you separate them, all letters you put in one tray and all the numbers you put in another tray. That is uh, unsupervised learning. You have not been told anything about that data. However, it is on the system to come up with a strategy to form groups of related objects. Neural network based learning. Neural networks are very classical kind of structures. However, their significance was lost until 2006 when Rumelhat and Geoffrey Hinton, they have come up with a backpropagation algorithm, and then they have demonstrated how neural networks can um, simulate the functionality of a human brain in a very rudimentary form. Uh, since then, neural networks became very prevalent, and they turn out to be the most successful models of machine learning and deep learning in these days. There are a multitude of examples of implementation of neural networks in natural language processing, where this Google Assistant and Apple Siri, Microsoft Cortana uses this deep learning neural network structures, and deep faces, which identifies a face in the Facebook, that also uses the same structure. There are tremendous number of success stories of neural networks. Even AlphaGo is a program that has defeated a human expert in games. Uh, Go game is considered to be the most toughest game in the entire world, and AI through deep learning has conquered that game and has defeated uh, the most expert player of Go game. Likewise, there are numerous examples which has used this neural network. Neural network, let me show you the image of neural network, how it look like. This is a very basic architecture of neural network. Each one is called as neuron. These are input neurons, these are hidden layers, and these are output neurons. Input is fed through this input neuron, and each connection point between each set of neurons of a layer with all the neurons of its previous layer, they they are labeled with weight. Each connection is labeled with a weight, and then this input and weight are applied together in a equation, and then some sort of result is sent here. Furthermore, this result is passed on to this with some kind of computation by using the weights. This process continues. uh, in deep neural networks, you have hundreds of hidden layers in between input and output. This is having only a single hidden layer. This is used only in very simple and straightforward kind of applications, but for a high end and a complicated kind of problem, this structure cannot solve the problem. You have to use Deep neural network structure looks like this, not even like this. More than this, there are even 150 layers also. Look at this. There are three hidden layers in this: input layer and output layer. This is our neural network. Neural network um, simulates the behavior of human brain. Human brain also has neurons, and neurons are connected. They have certain kind of weight, and all that kind of modeling is done in computer software. That is about neural networks. The network which I showed you is called as a feed forward network. In such architecture, the model takes the input, put on weights, apply computation, and produces a result, compares the result with the actual value. If there is a discrepancy, send the result back by adjusting the weights, further performs the same computation with the adjusted weights. This process continues until um, it achieves an accuracy uh, which is acceptable. Until then, this same process continues. The um, the values are moved forward and then returned back. While returning, uh, they adjust the weights and again move forward. This is the process of feed forward neural network, and this is only called as training. All right, next is supervised concept learning. Supervised concept learning is all about uh, going through the data and then generating output, comparing the output with the actual output. If both are same, the system has generated a correct result, and it is done for every instance of data present in the data set. The the data which is a collection of different instances formed together into what is known as data set. Data set is a collection of data elements. For instance, if I am creating a data set of all students of Nizam College, I may have some attributes: student roll number, student name, and student last semester result, and student punctuality, and student regularity, and students performance in mid exams, and students status of assignment submission. These are all features or attributes. And finally you have a outcome, which is the semester result. So what can be done with the data set is, you can take the data set and you can predict whether that student pass uh, in a semester. So you have the result, you have the semester outcome, you have all the features. What is done is, you train the system with the features without specifying the semester outcome or the end result, whether the student has passed or failed. That result is not given to the machine, to the model, and it is given only the features. The machine trains itself, and when it gets the output of the first instance, first student, it compares the generated output with the actual output, whether that student, suppose a student has passed. So if our model has resulted in pass, so both are matching, it goes to next instance, second student's data. Likewise, it does that for the whole set of data elements or instances present in the data set. So that is what is given in this. You have x1 y1, x2 y2, and x and yn. This is a combination where x denotes the input and y denotes the output. If we say that this x is um, punctuality, regularity, and if a student is punctual, result is pass. Student is regular, pass. Student pass in internal exam, mid exam, then final exam also pass. Like that, for every feature there is a outcome. uh, so that is mapped in while training a model. Look at this. What happens here is xk, label k. This xk can be a tuple. Tuple means a set of values. It has more than one value. As I told you, a student result may be determined by his regularity, his performance in mid exam, his assignments, and his punctuality. So all four values together come into x, and the label, which is the output, says uh, pass p if um, all the criteria. This is general case. There are some students who don't come, and outliers always exist in a data set. They are known as outliers. There may be students, essentially they will not come to college, they will not write mid exam, even then they will pass the exam, final exam. That's a different criteria. However, I'm talking about the general case. In the general case, if the criteria is met, then this is p. That is all about supervised learning concept. And then uh, when the output does not match with the generated output does not match with the actual output, there may be some kind of error. So that error, the whole idea is to reduce the error. If you are predicting for the percentage of marks for students, you go on doing the same process. You train the model. While training the model, you specify the features, and then model come up with the percentage or CGPA, GPA, whatever. Primarily in this concept, our idea is the generated CGPA must match with the actual CGPA uh, very closely. If not totally, should be very close. So suppose if the CGPA or GPA is 7.5, and our model is producing 6.2, there is an error rate of 1.3. So that error rate, ER, hypothesis is what is generated by the model, X is what is given, and for every instance, um, for every feature, k1 to n, such that h of xk not equal to label k. If label k is not matching with the h, which is the output of the model, if both are not matching, then error has to be reduced by following the same procedure as I described. Probability approximating correct learning. This concept was proposed by Valiant in 1984. This based on probability concept, and here what is said is you have a class and you have a unknown but fixed probability distribution, and the idea is to determine the number of examples in the training set such that at least uh, 1 minus delta probability with hypothesis H having at most E epsilon error for arbitrary delta less than or equal to half. And so the whole idea is about this. This hypothesis should be this error rate epsilon should be less than or equal to this hypothesis, and it can be greater than or equal to 1 minus delta, where CH, this like C minus S is the region of difference between C and H. C is a class. Class means the actual output value, and H is the predicted output value. So the difference between them must be minimized, must be um, minimal as much as possible. That is probabilistic approximating learning concept. Coming to supervised learning. Supervised learning, as I told you, does not specify the output. If you consider the same example of student dataset, what essentially happens is this dataset in unsupervised learning consists of student name, roll number, uh, punctuality, regularity, performance, assignments, but does not have the semester and result. End semester result is not specified, so there is no output value. What this unsupervised learning method has to perform is they have to perform the grouping of these students by finding the features which are similar. For instance, all those students who are in the range of attendance between 90 and 100, and it can be grouped in one uh, set or one group or one cluster, one segment, or you can group all the students based on their mid exam results. All the students who are scoring 90% or higher in mid exam can be grouped together in one cluster. Likewise, what happens is the system uh, itself has to determine criteria and then has to group the data instances in such a way that they resemble the actual grouping. Clustering is one such technique in which you perform the groups, you create the groups of, it depends on what criteria is chosen by the algorithm, and you know give out the clusters. Reinforcement learning, this is another kind of learning. So far the primary learning mechanisms studied are supervised, unsupervised. This is the third one, reinforcement learning. In supervised learning, data along with the um, output is provided to the system. Unsupervised learning is about giving out only the feature set and does not provide anything um, about the output of that. Reinforcement learning is the one uh, which provide some kind of feedback to the system, who is known as an agent. The system which performs a particular task uh, is known as an agent. Agent can be a hardware like a robot, or a software program can also be termed as agent. What agent task is? Uh, it is to perform a particular um, job given by the user. If an agent performs it extremely well, agent is rewarded with a positive feedback. If agent does not perform well and it gives a very poor result, as a consequence of that, agent receives a negative feedback. The agent job here is to perform a task at hand properly and get a reward. Agent wants a reward as a in the form of positive feedback. Then agent you know functionality is achieved if it gets a positive feedback, and hence uh, this type of learning is all about an agent performing a task and receiving feedback. Essentially what happens is agent learn basic kind of information like utility function. Utility function is about um, performing some useful task, and action value function is about if agent perform, in other words, action value function is uh, for a particular action, this is the value which agent receives. If action is good, value is high. Action is poor, value is low. That is how the reward is generated. So agent knows both the things, and agent performs the task. For instance, applications are given here. Agent doing checker playing program. Checker is a game. So if a agent plays that checker game and wins it, it gets a reward. Another application is in robotics. The agent is a robot, and it performs a cart pole balancing. There is a pole and there is a cart, it has to balance, and if it keeps the pole balanced and upright while staying in within the limits of the track length, then it is said that agent is performing well. So they are the two applications of reinforcement learning. There are several others. Inductive learning. Yesterday we discussed about inductive learning. Do you remember it? Can you tell me? Yes, inductive learning is about learning the patterns in a data. If I give you a data set, if algorithm is learning the pattern of the data, it is inductive learning. Deductive learning is deriving a new conclusion from the existing data, is deductive learning. Inductive learning is about learning the rules, the patterns, the form of data which has been provided to the learning system. Inductive bias, it means that um, there is a function. That function, you are trying to find the value for the function. For instance, you have to add a value, bias value. Otherwise, what happens is, if you don't add a bias, what happens is it gives similar result for all the data values. So what you have to do is, there is a extra value that is added uh, while you are performing the computations of the uh, data. You add a bias value, and then this bias and the data instance value together gives out a result which is non-linear in nature, and which may be closer to the actual output. If you don't use a bias, what happens is the algorithm memorize the training examples, and therefore does not impart any information about other unseen examples. It means that um, if I teach you about cats, if I teach you about 10 different kinds of cats, and you memorize 10 different kinds of cats structures, their features, their characteristics, if I show you 11th type of cat, you will not be able to say that that is a cat, because you have memorized the features, you have not understood it. That's why what is said is, don't memorize the concepts, learn the concepts by understanding, so that if you get a new kind of problem in the exam, you will be able to solve it if you understand. If you memorize mathematical problems and their solutions, you can solve only those problems which you have memorized. You cannot solve a new kind of problem based on the same formula, because you have not understood the formula. You have just by hearted the steps. When a new problem based on old formula is given, if you are clear about the formula and its application, you can solve it. Otherwise, you end up, uh, you know, not knowing the result. Hence, the same methodology is applied even for machine learning algorithms. Machine learning algorithms must learn the generalized concepts. They must not um, memorize or learn only the data samples given to them. They must be able to recognize new kind of data element which was not seen before. Uh, that is the essence of creating a successful machine learning algorithm. If a machine learning algorithm is able to predict or classify a totally new kind of data sample, data instance or data element which was not occurred in the previously seen data samples, then it is a good one. For instance, another example, if a model, machine learning model is being trained to predict the price of a house, essentially what happens is house price is determined from various parameters like the area land area on which the house is constructed, and the number of rooms, number of floors, the quality of wood furniture, the whether it is furnished or not, and uh, whether it has water supply, parking facility. There are a variety of features based on which house price is determined. When you are creating a machine learning model by giving huge number of data, samples of, let us suppose, 10,000 different houses which are having different parameters or same parameters, but different, they may differ in some or the other way. Of course, no two houses may be exactly similar, identical, may not be identical at all, and therefore you are training your model on 10,000 different house data. When the model is trained and when the model is ready to predict the price of a house, you provide a new type of house and ask the model to specify or predict the price. If the model is able to predict the price of this new house, which is not similar to, not exactly identical to any of the data previously seen, however there may be few similarities, but it's not identical. If model is able to predict that new house price effectively, accurately, then it is said that model has learned the generalization and has not memorized the prices of the houses given their parameters or features. So in order to make the machine, the learning algorithm more general, uh, more inculcating more learning ability, you need to add a bias value. And learning inductive learning framework is constructed by pre-processing raw input data and obtaining a feature vector that describes the feature of a data element or a data instance. For instance, here, uh, for a one particular data instance X, the name of the person is Sonam, color of the eye of Sonam is brown, and she is young and she is female. These are the features. and you have created an attribute value pairs out of these features. Inductive learning is all about generating knowledge about the data set. One mechanism to do that is decision tree. A decision tree can be constructed from the data. This decision tree looks like this. This is a decision tree about a four-wheeler. More specifically, it's about car. So type car, SUV, minivan. If there may be two doors, there may be four doors, there may be black wall, a white wall for the tires. Some other branches will come out based on the data features, based on the features. Okay, is a person fit? This is like deductive, uh, you know, deriving the conclusion, deductive learning. Uh, Forget about this question. Just think that we have a data set. From the data set, we have constructed this decision tree. If age is less than 30, yes means eats a lot of pizzas, yes means unfit, no means fit. From the data set, you have constructed this decision tree, that is inductive learning, and asking this question, is a person fit? This is a question like deriving a new knowledge, whether you are fit or not. How do you know that? By going through this decision tree, you can come to a conclusion whether you are fit or not. So that is you're deducing, deriving a new conclusion. This is, decision tree. ID3 is a kind of decision tree, is a type of variant of decision tree that has been developed, and that is another decision tree. Savings low, medium, high. Low means assets low, bad risk, good risk. Uh, this is savings medium. This is all about credit, or giving loan. You decide whether the income is low, medium, or high. High income, there is a most likely that it is most likely that loan is returned on time, perhaps before time. Low income, it is least likely that it is returned on time. Medium, it is likely that it is returned on time. So like that, you can create decision tree, and please go through all that is given. In tomorrow's class, we will learn about deductive learning. I hope today's class is clear. Please go through the topics once again. Any difficulty, any concern, you can ask tomorrow. Okay, bye.